Hello everyone, welcome back. So today's topic is going to be on creating a node in singly linked list. Okay, so before going into the actual concept how to create a node in singly linked list, let us know just brief about what is self-referential structure, because in order to create a node we need to know the concept of self-referential structure. What is self-referential structure? When a structure contains a pointer to a structure of the same type. See here, this is the structure and there is a pointer declared here, it is self, which points to which structure? It points to the same structure, just like your recursive function. What is recursive function? When a function calls itself again and again, such function is called as recursive function. In the same way, when a pointer points to the same structure, then same type of structure, either same structure or same type of structure, then it is called a self-referential structure. Now just see here the definition. It is a structure, struct keyword and structure name. It is a structure which contains a pointer, this is a pointer, to a structure of the same type. To which structure it is pointing? It is pointing to the same structure within itself. Okay, that's why it's called as self-referential structure. It refers to the same type of structure. Understood? Same type, it means it can either point to itself or it can point to another structure of the same type. You're clear? So how many member variables are here? There are two member variables. One is A and the other one is B. A can hold integer data type, integer value. B can hold character value. But self is a pointer where it is a pointer to the structure ABC. Okay, so note, we will use the self-referential structure to create a node of singly linked list. Okay, so we need to know what is self-referential structure in order to create a node in the list. Moving on to the next topic, node representation. So how do we represent a node? What is actually a node? A node will have two parts. It has two parts. What are the parts? One is the data part and the other one is the link part. One is the data part and other one is the link part. What is the data part? A data part, it can have more than one data values. Okay, so in order to store the values within the structure, we need to have datas. Okay, so it has data part. The other one is link part, where it can link one node to another node. This is a single node. When I want to create multiple nodes and provide link between the nodes, then I should have a link part, where this link is a pointer that points to the structure of the same type. You understood? So this is a general structure representation, graphical representation of the node. Okay, now coming here, struct node. So my structure name is node. Okay, you have one data type, that is int data, fine, and the other one is the link. This link is a pointer that points to the node, that points to the structure node. Okay, so it is pointing to the structure node. So in general, you can have struct node, a node, name can be anything. So since we are creating a node, I have given the name as node. You can have more than one data 1, data 2 of integer data type. You can have character data type, float data type, and so on. But in order to create, please note down, in order to create a singly linked list, we should have only one pointer, link pointer. There should be only link pointer, one link pointer. You got it? Now I'm going to, since I'm teaching you singly linked list, I'll be writing only one link pointer here. Fine. Next, see this example. If you go through this example, it will be very easy for you. Creating a node in C. How do we create? This is the standard code in order to create a node in C. Fine. Now I have two header files. The first header file is stdio.h. It is standard input output header file that supports printf and scanf statements. The next one is stdlib.h. If you remember if you just remember about the previous video of mine, I have taught you about dynamic memory allocation, malloc, and self-referential structure. If you have any doubts in both these topics, you can just go visit the previous videos. Fine. So stdlib.h is the header file which mainly supports the dynamic memory allocation, malloc, calloc, realloc, and free. Fine. So since I'll be using, in order to create a node, I need to make use of malloc. and should know in order to declare a structure, I have to make use of self-referential structure. So please note down these 2 points. That's why I'm adding the header file stdlib.h, because malloc is defined in the header file stdlib.h. Fine. Now moving on to the next one. So I need to create a node. What did I say? In order to create a node, I should have 2 parts. What are the parts? Data part and the link part. Since I'm going to store only one data, I'll be writing only one data variable here. So struct node, it is the keyword, and node is the structure name. Any name you can give. So within that, int data. Data is a variable that can hold integer data type. Coming on to the next one, struct node star link. So what does it mean? Link is a pointer that points to the structure node. Since it is structure, the link is pointing to structure node which is placed within the node structure. It is called self-referential structure. So this is the first part that you have to write for any node creation. Got it? So after that, coming here, struct node star head is equal to null. There's one more pointer. If you observe here, there are 2 pointers here. One is within the structure. See, I told you for singly linked list, there should be only one link which is kept within the structure. Fine. Next, this is to create one link to another link, one node to another link. To provide link between one node to another link, I am using this particular pointer link. Fine. Now coming to the main function, we are again creating struct node star head. Now head is also a pointer. There's one more pointer which is pointing to which structure? Node structure, and it is initialized to null. So which means we will have a head pointer and it is equal to null. After this line, this is how the coding looks. Struct node star head is equal to null. So head is a pointer, and what am I initializing? Null. Of which data type? Which structure? Node. Data and link. So you'll have data followed by link. Clear? This is the node. Now if you understand, it is, see, just by creating a structure, declaring a structure, it doesn't mean we can create a node, but we have to allocate memory for the structure. So what should we do? We have to allocate memory using malloc. Got it? So we are allocating memory. If you see here, after this line, this is the structure. One is the structure, the other one is the pointer. Head is the pointer which is initialized to null. Okay, now after this line, what I'm doing here, struct node star malloc size of struct node. So we are going to allocate memory space, but malloc will allocate memory. A large block of memory will be allocated using malloc. But what is the size? It is size of struct node, which means I'm going to allocate memory of structure for both data as well as for the link pointer. Data variable as well as to the link pointer. So it is size of struct node. What are the size? The total memory allocation for both I'm going to allocate. So what will happen after this line? If you see, this is data point and this is link. This is the name of the node. So there are 2 parts. Okay. Now initially memory is allocated, and after that we have one more pointer. What is the pointer? Head. And what is the value of head? It was null here. Okay, it was null. Now malloc size of struct node. So this is how we have created memory allocation. If memory is allocated, suppose 1000 is the address. 1000 is the address where the memory, the first byte of the node is being created at address 1000. Fine. Then after that, after successful completion, malloc will return a void pointer. Correct? It returns a void pointer. Then we are typecasting. Please see my previous video of malloc. You will understand what is actual syntax of this. Struct node star, which means I'm going to typecast it, and please make a note that this particular typecasting is not required. We can just leave in henceforth videos. I can just leave like malloc size of struct node, which means my node is created. Only after this line, only after the second line, node will be created with 2 parts, data part and the link part, with the address 1000. Fine. So now after this, what am I doing? I'm pointing the first byte. After allocation, the first byte of the pointer is pointed to head, which means now head value will be pointing to 1000, the first node. I'm providing a link between the header, the head, and as well as my node. Initially head was null. Now what is head? Head is equal to 1000. Now it will be replaced with 1000. You got it? So struct node star head. Star is one more pointer with value null. It is a separate pointer, and this particular line will create a node of data and link paths. Fine. And address will be allocated, because after declaring, this particular line is mainly used to allocate memory to the structure node. Fine. The name of the structure is node, 2 paths and 1000. And after this, after successful completion, the first byte address will be pointed to head. Now why I am naming this particular pointer as head? Because it points to the first node, the initial node. That's why it's called as a head pointer. Any pointer that points to the first node will be called as head pointer. Fine. Now there is a link. Now the pointer is pointing to the node. Why I should do this particular step? Why this particular step is required? Head is equal to, because in order to access data or store data, retrieve data or add data into the structure, we should have a pointer variable. So head will be used in order to add values and retrieve the data. See the next line. Head pointing to data, arrow operator. Arrow operator is used in order to store value. Okay. So head pointing to data. Head is now pointing to 1000. So at 1000, the first part, data part, what value I am storing? I am storing with 50. So the empty values will be replaced with 50. Then next, head pointing to link. Head is pointing to 1000, and the link part I am adding with null. You got it? So this is how these two lines are mainly used to access the member variables of the structure, adding value and the link with null. If you don't specify this null, then the default value will be a garbage value. Fine. After this, what is the next line? I'm trying to retrieve the value that is stored within the data part. So printf %d, what value? Head pointing to data. What is head pointing to data? It is 50. So the output will be 50. Understood? So once again, I'll just repeat. So there are two header files which is required. The first header file is mainly used to store the standard input output header file. The second one, since I'm using malloc, this particular line, malloc is mainly used to create a node. For creating a node, memory allocation of memory for a node, and it creates a node. Then followed by struct node star head. I have one more pointer that is actually pointing to null, where it is mainly used to access the data part, to add values and retrieve values. After that, using arrow operator, I can add values. Okay, and again using arrow operator, I can retrieve the value. Okay, so I hope you understood the video. Thank you.